So indexing helps us find where something is in a text, and we looked at a couple of versions of that, a version based on a list of strings and a version based on indexing within the string itself. But sometimes we don't know exactly what we're looking for, or we're looking for a group of things that are related in some way, and what we want for that situation is what's called pattern matching. So here we're going to look at a couple of examples of how to do pattern matching with our strings and with words more generally. One thing that we can do, for example, with pattern matching is we can use dictionary information to generate terms of interest that may be related to a particular term. So for example, the word stem command in Mathematica removes plurals, inflections, things like that. If we look for the stem of officer, it knocks off the ER at the end and gives us this stem here, OFFIC. And we can then use that with dictionary lookup to find words that have 0 or more characters preceding that OFFIC and 0 or more characters following it. We say 0 or more in a pattern with this 3 underscores, and we use this double tilde notation to join pieces of string patterns together. So let's look up all of the words in our English language dictionary that contain OFFIC. And see, it gives us a lot of things: office holder, office holders, officialdom, unofficial, and so on. So if we were looking for the word office, we might think, okay, office, offices, but we may or may not be interested in words that are related to that. We can use intersection, once we have such a list, to find out if any of those words occur in our text. And here we're just going to look up words that contain OFFIC with the intersection of that with the words in Hamlet's soliloquy. And only the word office appears there. We can also use a command called word data to search for synonyms. So for example, if I think of the word calamity, I can get a list of synonyms for that: cataclysm, catastrophe, disaster, tragedy. If I look for synonyms for troubles, I get a different list. If I'm searching for a particular concept, sometimes I'm not searching for a specific word so much as I'm searching for a specific concept, and it's there that the power of being able to leverage computational thesauri comes in handy, and dictionaries. Now another thing that we can do is we can find terms in the same sentence. So we're going to take Hamlet's soliloquy, and this time we're starting with a string. This time what we're going to do is we're going to break it into a list of strings where the strings are not words, but they're sentences. We do that with text sentence. We can look at the first sentence in the list. I put sentence in scare quotes there because in the soliloquy, whether this is actually a sentence per se is a little ambiguous. But anyway, this is the first thing that's been broken down into a sentence. And if we use string cases, we can look for, say, sleep. We find that sleep appears twice here. However, we have to be careful if we're using the string cases command, because it's not paying attention to word boundaries unless we tell it to. If we look for the word and in that first sentence, it gives us 5 instances. But if we are explicit and we say, show us a word boundary joined to and, joined to another word boundary, it only gives us 4 matches. So what that suggests is it suggests that there's a string in this sentence which ends in AND, but is not the word and. And in fact it's right here, it's 1000. So we have to be careful to be explicit about word boundaries when we're doing this kind of searching within strings. So here I've created a function, and I'll let you read this to practice your code reading. What it does is it lets me search to find one instance of a keyword near another instance of a keyword within a list of sentences. And in the next expression, I show how that works. I'm going to look in the text sentences, so we've split the soliloquy into a list of sentences, and I want to see all the sentences that mention die or death and sleep. That's what that says. And we've returned the output in this nice interface, which is called a tab view. This shows us the first case that includes sleep, near, die, or death. This is the second one, and this is the third one. Now it helps to know a little bit more about string patterns. So in string matching, if we use a single underscore, that matches one character. This, for example, is showing us, we go through, and I'll just read through the code to tell you what it's doing. We start with the list of words in our text. We search for all cases where there's a single character joined, any single character joined to an M. And then we flatten that list because it has a bunch of sublists in it. And finally, we get rid of all of the duplicates. So these are all of the words these are all of the cases in the soliloquy where there is a letter followed by a lowercase m. If we want to match one or more characters, we use double underscores. So this next example, same kind of expression, but this shows us all of the words that end in ly. So devoutly, contumely, fly. We could do, if we put the pattern, rearrange our pattern so that we specify what's at the beginning rather than at the end, we can see all the words that begin with QU. And in these examples, we're looking in the list of words, but we can also do things where we look inside of our list of sentences. So for example, let me show you the output here. What this does is it looks through our sample text sentences, finds all of the string cases where there is a single character before a D, and then it flattens it and gives us a unique list. It deletes the duplicates. And we can see words that end in nd, like and thousand. There are words where there's a space before a d. That's a lowercase d at the beginning of the next word. He uses this apostrophe d in one or more places. He uses ed endings and so on. Now we can also, if we want, match a word character by using this special pattern, word character, which will match any letter or any digit, but not punctuation. So if I run this command, this expression here, it's the previous list, but I've gotten rid of apostrophe D, and I've gotten rid of blank space D, because neither of those things is a word character. We have a command in string matching called except, which lets us pull out the opposite of things that we ask for. So if we, instead of asking for a word character before D, this gives us everything that's not a word character before D. That gives us the space D and the apostrophe D. And we can search for things where elements are repeated using two commands, repeated, which is 2 dots shorthand, or repeated null, which is 3 dots shorthand. This expression here searches for one or more word characters joined to and. So this shows us, this thing here means one or more word characters, so that gives us 1,000. If we search for 0 or more word characters joined to and, that gives us and 1,000. And we can use patterns for start of string, to pick out words that are the first words in a sentence. And there's also a pattern for end of string. And let's do this one here. Words at the end of string that are preceded by one or more punctuation characters. Sorry, words at the end of the sentences that are preceded by one or more punctuation characters. I'll just read through this for you so that it's more explicit what it does. We say, let's match this string cases right here. That includes the whole expression. And so what the string cases we're looking for are, it looks like this right here. So we're looking for one or more word characters joined to something that's not a word character, one or more of those, joined to an end of string. Now exclamation mark, of exclamation mark, bodkin question mark, sleep exclamation mark, and D period. I've put some of these examples in here not because you're probably looking for something like that, but because If you're looking for something, there's often a string pattern to find it, but coming up with those string patterns can be it can take a bit of trial and error. There's one more thing that we can do, and that is we can refer to a part of a pattern, we can give it a name, and then we can do something with it. So let's look at this first expression here. What this does is it gives us all of the words following the word to be, to suffer, to take, to die, and so on. To, the preposition to, plays a very important role in the soliloquy, of course. But suppose we just wanted to get the second part of each of these. We don't want to keep repeating to, we just want to know what the words are. We can do that with this next expression. Be, suffer, take, die, sleep, say, and so on. Now, how does this work? I will again highlight the pattern. What this says is it says, give me all of the expressions where to is followed by a white space character, a blank or a tab, followed by a word, one or more word characters. But I've given it this section here a name. I've called it following, and then I use the arrow and I say just give me the part that says following and not this part up here that's part of the matching. And so instead of giving me to be, it just gives me be. Instead of to suffer, it just gives me suffer, and so on.